Here's a fun story. I've managed to break my phone by just applying a wallpaper to it. And I'm not alone. It seems like hundreds of people in the last week have had their entire phones wiped because of this photo. I first saw it on Twitter. Ice Universe, famous leaker. He basically made a post saying, people are spreading this wallpaper. Don't apply it. Please, don't apply it. But of course people did. What would he know? He's just a world-renowned smartphone enthusiast. And I don't think I've ever seen karma bite back faster. The comments section is filled with two types of responses. People who've applied it and got away with it on their phones, and who seem to be using it as a way to prove they've picked a superior device. And the other, less fortunate group who've applied it and quickly realised they probably shouldn't have. They post the videos of their devices basically going schizo. In a lot of cases, they've had to wipe everything. Listen to the cat, people. The cat never lies. Anyways, there are three unusual things that happen here. Number one, that whether or not your device gets destroyed depends on who made it. For example, Google and Samsung, they're no-goes. Don't go there. Two, if you upload the photo to a social media site like Weibo and download it again, the colors will shift to this less vibrant version, and it's safe to use. And three, you might have noticed I've been showing you this wallpaper on my Samsung phone this whole time. And the way I've done that is just by taking a screenshot of the image and setting that as my wallpaper, which is safe too. On the face of it, none of this makes sense. So what the flip is going on here? Well, I spent the last 3 days trying to find out. Okay, my initial assumption was this is malware. Someone has obviously designed this wallpaper to conflict with the code of Android and start crashing phones. The resolution is exactly 1440 by 2560. That is the current standard Android wallpaper resolution. It has been made to apply as a wallpaper. And add to that, I've never in my life seen a wallpaper that can so consistently kill phones. What are the chances someone came across that by accident? Well, the more I dug into it, the more it seems like my initial assumption was wrong. I thought the best way to find out if something was malicious or not was to find out where it came from. So I did a reverse image search. Google Images has a clever little feature now that allows you to use an image to search for similar images. And by doing this, within 2 minutes, I traced the cursed wallpaper back to its original source. Turns out, the wallpaper being circulated around was not the original photo. This is the original photo from hdqwalls.com. And if you download the original and check the data of the image, you can see it is just a photo taken from a Nikon D850 camera. Surely that can't be the problem. This is just someone who's taken their camera to a national park. Maybe they've camped out overnight to get this stunning shot of a sunrise. That's not going to break your phone. Plus, a lot of the people online were saying that the reason the cursed photo was crashing phones was because it was encoded in a color profile called Google Skier. But seeing as I now managed to get hold of the original photo, and I could see that this wasn't a Google Skier image, I applied it to my Galaxy S20 Ultra. Big mistake. Gone. Finito. Galaxy S20 Ultra, in one fell swoop, nuked. I couldn't get past my lock screen, and even safe mode wouldn't let me recover it. All data on that phone that I didn't back up is gone. And I won't lie to you, this felt like that part in a detective movie where the detective gets too involved in a case, and the criminal isn't happy about it, so he starts taking away family members from me. I've lost my data trying to fight for this cause. I thought it would be okay. I thought this is the original image, it's just a photo, this can't be the problem. But I was wrong, and I'm a little bummed. But a sub to the channel would be amazing. But anyways, we can see that this crashing then wasn't caused by some malicious third party who tampered with the image afterwards, like I'd initially suspected. It's the original photo that's enough to break your phone. So that just leaves the question, how? Okay, let's talk about color for a minute. Take a look at this diagram. This represents all the colors that us humans can see. This triangle inside of it, that's the sRGB color space. It's a subset, it's a small section of the full range of color. And more importantly for this case, it's the only set of colors that Android really understands. So yes, most Android phones historically, they haven't been able to display the full range of color, but they're limited like this for the sake of consistency. sRGB is what almost every device is calibrated to. Digital cameras, printers, the internet. So by having an operating system based on it, you can ensure that, let's say I post something on Instagram for example, then when you see that post on the other end, it can make sure that you're seeing it in the way that I intended it. Or that when I see a photo online and I print it out, it should look pretty similar to the preview I saw on screen. But there are many different color spaces. You've got Adobe RGB as an example, which has a wider range of color. Or if you wanted to go a bit crazy with things, ProPhoto RGB, which is this huge triangle here. And this all seems really complicated, but all it means for this is that if I convert an image from sRGB to Adobe RGB, it's going to effectively stretch the color space. The color that was previously here gets mapped to here. So this is a random photo I took a few days ago in sRGB, and moving it to the wider Adobe RGB, it just gets more vibrant. And the same will happen again if we move from Adobe to ProPhoto RGB, because these points are moving to these points. So what's that got to do with the sunrise of nightmares? Well, it turns out ProPhoto RGB is the color space that this photo is encoded in. And you can see the appeal of doing this. Now that I know how it was encoded, I can actually flick it back to standard sRGB, and it becomes this. This is the true original photo, and all of a sudden, it doesn't look so hot. So whoever took the photo probably just thought, oh, I really like the colors in ProPhoto RGB mode, I'll just export it that way. And this explains what I mentioned earlier about Weibo. Weibo doesn't support this ultra-wide color space. So if you upload a ProPhoto encoded image to Weibo, the reason it changes is because it's actually being converted back to sRGB. So okay, we've established that something about this color space is causing a problem, but it's not as simple as that because Android can actually handle ProPhoto. Even though Android supports sRGB only, it is programmed to convert images from other color spaces back to sRGB, just so it can have that level of consistency. Trust me, I wish this was simpler too, but we're nearly there. It seems like this conversion is actually where the problem is, where Android is trying to turn this ProPhoto into an sRGB image. That's the bottleneck. And you won't believe this, the reason these devices are crashing all comes down to one pixel. This one right here, according to David, who I was talking to about this. Google's color engine can't for the life of it convert this one pixel to sRGB, specifically because of the luminance of it. Luminance is basically brightness, but just adjusted for the way that we humans actually see things. Because you might know this, humans see green tones far better than we see red tones, and we see reds better than we see blues. So the luminance of a pixel on Android is calculated by this formula. It gives green the most weight, then red, and then blue. To put it another way, you need a lot of blue light to give the same luminance as a little bit of green light. Anyway, the max value of red, green, or blue individually is 255. So the way this code is put together, you shouldn't be able to get an overall combined value past 255, because all the formula is really doing is taking a weighted average. But for this one particular pixel, it just so happens that the red, green, and the blue values are all incredibly high, 255, 255, and 243. So plugging it into the formula, we get red as 54.213, green as 182.376, and blue as 17.5446. If you add all these up, you get around 254, which is still under 255, so what's the problem? It turns out Google uses a type of rounding that basically rounds each one of these numbers up. So those RGB values actually end up as 55 plus 183 plus 18, which gives 256, which is over the theoretical maximum of 255. Error. One number in one pixel is enough to send your device into this spiral of doom. In a normal situation, when Android encounters a problem like this, it'll try to close the process. But by setting it as your wallpaper, Android can't just close it. You're creating a permanent loop of errors as it keeps trying to fix itself and fails. And this also explains why screenshots of the image are safe. There's a bit of a misconception with screenshots. When you screenshot a photo, your Android phone is not making a copy of the photo. It's creating a new image that by default is going to be an sRGB shot, because it's Android. So that conversion that's causing all the crashes doesn't need to occur. If you're wondering why only some devices are broken by the wallpaper, it's because they're all phones that use Google's default color engine, which is the part that's messing up the conversion. As for whether you should worry about it, not really. I mean, obviously don't apply this wallpaper, ever, but a bunch of developers have been working for hours continuously trying to recreate the error, and we couldn't. So the chances that you're going to see this popping up in other wallpapers, I think, is pretty low. But just for peace of mind, the next Android 11 should be fixing this problem anyway. It is a pretty easy one to solve. You just need one line of code that says, if this value is above 255, then make it 255. Anyways, this has been a stressful video to make. If you enjoyed it, do consider subscribing, and huge thanks to Michal on Twitter and David, who's working on his own custom ROM called POSP right now. Those guys have helped out massively with this. With that being said, my name is Aaron, this is Mr. Who's the Boss, and I'll catch you in the next one.